So it seems like a lot of tech guys here, and that's okay, that's good. I really enjoy this because the tech guys are really the audience that I was targeting. So hello everybody one more time, those who watch us live and in the record. My name is Shevshenko. I'm the head of the Exonum project. Exonum is a framework for private blockchain solutions. So everything you'll hear today would be around the blockchains. This is one of the projects that we run in the Bitfury Software Research and Development Department. It's live for almost 2 years, and recently we've made the first public release, so now it is available to anyone on the GitHub. And today I'm happy to give you a brief intro into what we've developed and our plans on future of the project. Well, we are going to structure the webinar the following way. I'll be telling you about the project for about 20 to 30 minutes, while you'll be able to ask questions to my colleagues. And at the end, we will have some time to elaborate a little bit on the questions that are the most relevant to our vast auditory. So without wasting time, let's begin. And to begin with, I would like to talk a little bit about the blockchain technology itself. Well, I see that some of you know about blockchains. So for these, I just want to place accents. And for others, I would like to give you some kind of an insight into what is the blockchain technology and how we can use it. First of all, a blockchain is a database, but with some specific features. A blockchain is distributed, which means that a copy of it is stored on several computers. That means that there is no single point of failure in the system. And this feature is not unique for a blockchain. There are other databases which are distributed, Cassandra, ClusterXDB, others. However, the notion of the absence of a single point of failure is very crucial for a blockchain, and you'll see it later in other concepts that we're going to develop. The second thing is that it has tamper resistance and an authorized transaction history. And these two are assured by a cryptography which is laid inside the blockchain. This results in the impossibility of modification of a database log, even by the admins of the system. You see here that there is a difference between the database log and the database itself. So you are able to modify the information that is stored in the database, but you cannot change the history of the changes of the database. It may sound a little bit weird, because in ordinary databases you can do anything you want, but this is the feature which enables the absence of the necessity of trust to the system maintainers. And the other thing is the auditability. A blockchain is not a blockchain if you cannot verify the stored information. And this verification is assured by the same cryptography we use inside the blockchain. Last two features are specific to blockchains and are in fact the essence of the technology. So if someone tells you that here's the blockchain that can be modified, then this is not a blockchain at all. Nowadays, blockchains are divided into two categories. The first one is public blockchains. The second one is private and permissioned ones. The difference is in the way how people can participate in the blockchain lifecycle. If anyone is able to add information to a blockchain or generate blocks of transactions, or in other words, introduce some changes to a database, then this is a public blockchain. For example, Bitcoin blockchain and Ethereum blockchains are public blockchains. So if you want to be able to mine Bitcoin blocks, you need to run a full node of Bitcoin on your computer, and that's it. On the other hand, if you have a limited number of validators or nodes who participate in the consensus of what block should be added to the blockchain, then this is a permission blockchain. And from the definition of permission blockchain, you can see that it is more suitable for the enterprise use cases and corporate use cases, because you probably do not want to give an ability for anyone to add some information to your blockchain. So the difference is significant, and it results in different algorithms behind the scenes, and of course in different problems which this blockchain solve. Exonum itself is designed to be a private blockchain. So we are going to talk today about private and permission blockchains. So what Exonum is? First of all, it's an open source framework. And this means that it is free of charge for any users, even for commercial applications. So any one of you can go now to our GitHub and download Exonum and start playing with it. The framework means that this is not an application. You cannot just install it and use it. It needs to be incorporated into other applications. So you can't treat it like a built-in database. You can't treat it like a built-in database, which is accessible only by a specific program. We've tried to make Exonum as modular as we can, so now you already can see several modules which combined can solve your particular issue. We hope that community will generate vertical solutions on top of Exonum to meet the needs of specific industries, while Exonum itself is a horizontal solution for the blockchain databases. Because of Exonum being a horizontal solution, it has no business logic inside it. No stuff like unspent transaction outputs like in Bitcoin, or cryptocurrency like in Ethereum, nothing inside, just plain database with the ability to store the information. If you need several tables in this database, you need to specify what tables you need to have, what are the fields of these tables, and what is the way, what is the approved way how to change information in this database. And because of the need of robustness of the system and transparency, we need to make it the most secure way we can. And that's why we use the most appropriate tool for it, Rust programming language. This is the one of the most secure languages up to date. The compiler can check, well, it has powerful static code analysis tool, and during the building of the application, it analyzes the code. And in case it has memory errors, then it just won't build. And for your information, memory errors now are something around 90 to 95% of all of the errors in the applications. Rust started when Mozilla guys said that we do not want to fix bugs in Firefox. We would like to develop a tool which will force us to write the code without bugs. Because of this decision of using Rust programming language, our development is slower. Obviously, the language is quite new. There is not that much Rust developers. However, using it, we're sure that we are making the safest code base we can. Now, when we all know about blockchain and what Exonum is, let me show you an old picture of the software development process. People often do things that do not correspond to the definition of what they need or intended to do. And because of hype around the blockchain, everybody says that we are developing a blockchain solution, when in fact it is not. And to encourage you and these people, I would like to cite Zig Ziglar, who was one the day will come when you can do what you can, but that you won't do, and when you want to do it. Applying this to Exonum, I can say that we've developed the project the way we need it for it to become an authentic private blockchain solution. And because of this, all of us now can do what we want to do with it. I started with blockchain features, and I'd like to continue with them. Next several slides are going to be like the following way. The feature we want to get and the Exonum architecture solution that we have, which enables it. And to start, I would like to go to the consensus mechanism. So the consensus algorithm is something that lies inside the blockchain, and it is the majority of the logic that works within the blockchain. And because we are talking about the absence of single point of failure, we need to make this algorithm resistant to malicious behavior. And this malicious behavior can be a behavior of some third parties of the system. So, for example, it should be resistant to denial of service attacks, but also it should be resistant to malicious nodes and malicious validators inside the system. And there is a consensus algorithm which is tested and which is resistant to this malicious behavior. It is called proof of work. It is used in the Bitcoin and Ethereum at the moment. Now, the problem with the proof of work consensus mechanism is that it is really slow and it is not scalable. And this is because it consumes a lot of electricity. It generates, well, it is purely the securest stuff that you can find in the world. However, it is not scalable. So Bitcoin is capable of running for about 2 to 3 transactions per second, while, for example, Visa network is capable of running up to 50K transactions per second in peak, and mean something about 2.5 thousand transactions per second. This is several orders of the magnitude more than the Bitcoin. So Bitcoin is not suitable itself for the commercial applications. So we need to use something different. And we can do because we are not operating in the public blockchains domain, but rather in the private blockchains. And we've developed this kind of algorithm. It is called the Byzantine fault tolerant algorithm, and this is only the feature of the algorithm. And by saying Byzantine fault tolerant, this means that it can tolerate Byzantine or arbitrarily faults in the system. So some nodes may go down because of maintenance. Some nodes can be hacked, but still the system will propagate in time and generate new blocks. We are not the first guys who invented this. We tried to cherry pick of all the recent researches of all the algorithms here and tried to make it the most usage-oriented algorithm up to date. If you want, if you're in, put there all the specification of the algorithm and all of the, where is all the description of all of the stages that we have there, and all of the conditions, how you transition from one stage to another, and so on and so forth. Relatively soon, we are going to publish a white paper just about the consensus algorithm that we have, with strong mathematical proofs that this algorithm works under the assumptions of the Byzantine fault tolerance, and it can propagate in time, and of course that we do not have forks in our system. So, for example, in Bitcoin blockchain you have forks, so the ability to have forks extends the clearance time of the transaction. So if you want to be sure that your transaction is added to the Bitcoin blockchain, you need to wait several blocks to be built on top of the block with your transaction. Nothing similar in the Exonum. Once the transaction is added to some block, then this means that it is stored in the blockchain forever. Of course, because we are talking about the security, we need to use the top-notch level of cryptography inside our system. So we use a very good elliptic curve for the digital signatures, and all of the messages within the system are digitally signed with ED 25519. And for the hashing algorithm, we use the same which is used in the Bitcoin, which is SHA 256. And under all of these assumptions, we've run our benchmarking over 7 nodes in the network, which were situated on 4 different continents, with a database on the disk, so not in the memory, with only a single core per node, which was run on the Intel 2.4 gigahertz processor. And all of this was in an ordinary AWS cloud. And on this benchmark, we get the result of sustainable throughput of 3,000 transactions per second, with a 2.5 seconds clearance time for every transaction. So literally, by having this result, we can say at the moment that actually Exonum is capable of running the Visa network with the Visa's mean throughput at the moment. So Exonum is, even at the moment with the first release, we are capable of doing the projects of that size. And this is quite a good result. Now, let's talk a little bit more about the security and the resistance not to a single malicious node, when all of the maintainers of the system want to rewrite the history of the blockchain. It cannot be easily done within the public blockchains because of this consensus algorithm that is used there, proof of work. You need to spend some time and electricity in order to generate Bitcoin blocks. But if we are talking about Exonum blocks, you need to just digitally sign them and come to a consensus between the validators. So that if the validators wants to discard some of the changes and put some other blocks into the Exonum blockchain, they can do it with the speed of 3,000 transactions per second. And this is a problem. And actually, this is not the problem of Exonum blockchain. This is a problem of any private blockchain. So if anyone tells you that that there is a private blockchain which is fully resistant to any changes, then you need to question this person how you can tolerate the situation when all of the system maintainers want to change something in the blockchain. And Exonum's answer to this is the anchoring algorithm. And the anchoring algorithm is just periodically saving a hash of a system state to the Bitcoin blockchain or to some other public source. Again, we are not the inventors of the approach. It started in the US TOX exchanges, when they put the information about the rates into the daily newspapers. So they were putting the information, their internal information, into the public source in order to prove to their customers and the clients that they are not cheating with them. We're doing the same right now, but instead of using newspapers, we're using Bitcoin, which is much simpler and easy and more digital and so on and so forth. So the reason why we are using anchoring is that we want to prevent the situations when the system maintainers want to change something. So you have these 3 levels of the security of the transaction processing within the Exonum system. The first one, or the red one, when the client of the Exonum blockchain sends the transaction to the Exonum itself, and the transaction goes to the pool of the unconfirmed transactions. This means that it is not yet committed to the Exonum blockchain, and it can be discarded by some reason, or maybe by some malicious behavior of the validator or something like this. Yeah, and the user is not sure whether this transaction will be recorded. In 2.5 seconds, go to the yellow zone when you understand that that the only thing that can change the fact that transaction is recorded to the blockchain would be the collusion of the supermajority of the validators. And if you wait for additional 10 minutes, or maybe, well, it depends on the anchoring window that you have, but if you are anchoring every 10 minutes to the Bitcoin blockchain, then you need to wait for additional 10 minutes for your transactions to be anchored to the Bitcoin blockchain, which means that if system maintainers want to change this and want to delete your transaction from the blockchain, they need also to hack Bitcoin blockchain. And the cost of hacking of Bitcoin blockchain is somewhere around 10 billions of US dollars. The hack would be very visible because there are only 2 companies in the world who are producing the hardware equipment for the Bitcoin blockchain, for Bitcoin mining. One of those companies is Bitfury, the other is the Chinese company. And well, it would be very, very visible, and well, literally it is not going to happen under any circumstances. So yeah, 3 levels of the security, and the last one, the anchoring part, is very of course you need to spend some Bitcoins on this. And the transaction in the Bitcoin blockchain, it takes about $1 and $1.50 to be recorded in the Bitcoin blockchain because of the fees that there are in the Bitcoin. But if you have only a single anchor a day, so for a month, you will have less than $50 of the unprecedented security, for the unprecedented security of Bitcoin blockchain, which is simultaneously transported or extended also to your Exonum blockchain. And I think that for big corporates, $50 is nothing. If you won't even raise the security of your system, you can shorten the anchoring window and make the anchoring happen every 6 hours, or maybe 4 hours, or maybe even 10 minutes. But of course, you need to pay a little bit more. The notion about the anchoring algorithm is very simple. You can say that, well, it can be applied to any of the blockchains that we have already in place. However, it is not that simple if we are going to talk a little bit about the development of it. You can recall the notion of the Byzantine fault tolerance. And because we are working under the assumption that any of the validators can be malicious, this means that we need to make the anchoring algorithm also Byzantine fault tolerant. And because within the algorithm we have this communication with external system, which obviously Bitcoin is, we need to allow for different Bitcoin behavior. So every and each of the nodes of Exonum nodes communicate to its own full Bitcoin node, and the states or the view on the state of the Bitcoin may vary. Bitcoin also has forks, and we that the anchoring algorithm is quite complicated thing at the moment, and it takes around a half of the Exonum core number lines of code for us to build the anchoring algorithms. 25,000 lines of code in Exonum core, while 10,000 lines of code in anchoring module, a single module. Light client. Imagine the communication with your bank when you are using your internet banking application within your smartphone. You send a request to a bank, please tell me the amount of money that I have on my account, and bank sends you back the information that you have, for example, $1,000 or something like this. And you need to trust this information. Of course, you can have the secure channel between your application and the bank, but you are not sure whether the information that is provided to you by the bank is correct. And there is no way for you to check whether it is the correct information. If we are talking about blockchain technology, because of the use of specific data containers in the blockchain, which are called Merkle trees, we are able to pass, along with the response, the cryptographic proof of the fact that response is correct. So this means that because we are able of doing this, and if we want to remove this necessity of trust, then we need to have some software on the client side which will be capable of checking the proofs. And again, I'm talking about the private blockchains in general, and well, not only the private blockchains, but also about the public blockchains, about the blockchains in general. And this is not something specific to Exonum. This is a common problem, and every blockchain solution needs to have an answer to the problem. And in our case, we've developed the Light client. This is a very simple JavaScript library, which can be used on the client side. And the major purpose for this application is the verification of these cryptographic proofs. You send the request, you get back the result, and also a proof that this result is the correct information which is stored in the blockchain. Also, a client helps you form, sign, and send transactions to the blockchain, and also send requests. But this is, some kind of additional features. The major thing is that we need to verify cryptographic proofs. This brings the auditability and transparency of the system live. Okay, I've tried to give you an insight into the architecture solutions that we've made to make Exonum an authentic blockchain. Do you remember the slide with the swings? Now, I encourage you to use Exonum the proper way. If you need an ordinary database, or you just want to automatize your work with spreadsheets, or you're looking for ICO just because it seems like an easy money, then you probably do not need a blockchain solution. On the other hand, if you have a solid use case around transparency, data consistency, data auditability, which lies inside a single company or a consortium of companies, then Exonum may be a good fit. Use right tool to solve your problem. Now, Bitcoin started with a good idea, which now changes the world. But there were a lot of work put into the Bitcoin after the initial release. The same stands true for the Exonum. And I would like to share with you our roadmap and some additional thoughts on the direction that we are heading. We want to transform Exonum from the framework to an application. Well, we want to keep, actually we want to keep both of them, a framework and also a simple application. So a user can, a developer actually can download Exonum from our website or from GitHub and run it. And it would be plain, empty Exonum without smart contracts, without anything inside. But it will be live. And in order to do it, we need also to implement the thing that is called dynamic services or dynamic smart contracts. If we're talking about Ethereum, then you are able to upload your smart contract, and right after it is accepted by the network, you can use it. The same is not true for the Exonum blockchain at the moment. So in order to do it, you need to upload new software, and you need to rerun your system, you rerun your servers. It is not very convenient. However, it might be appropriate for the corporate solutions because you are not changing the business logic very often. The second thing that we are working on right now is Java binding. So we understand that Rust programming language may be good. It is very good for the core of the system. However, if we want to spread Exonum and raise the knowledge about Exonum among the developers, we need to have some additional languages that can be used within the Exonum. So this and the language that we choose was Java, because obviously it's one of the most popular programming languages at the moment. And of course, because it has a lot of different tools which allow you to go through the security checks, through the DevOps processes, and so on. So this Java binding will consist of two separate parts. The first one is just the interface for the public API for Exonum, so you can use Exonum from Java applications. The second one is the ability to write smart contracts, or how we call it, services, in Java instead of Rust. And this is a little bit more complicated because we need to make sure that our Rust code is capable of running Java virtual machine and capable of starting these Java services inside it. Also, there is an additional idea which I think that is one of the most interesting things to implement, and we call it the interface description. Imagine you can that lay down almost in human readable form, in almost English, the description of your particular system that you want to build on top of. So I would like to have these two services. Each of them has 5 tables. The first one has in the tables of fields, and there are 10 transactions or types of transactions that can be and well, itself it is not that beneficial that we can put this description, yeah, but it is enabled to 2 major features that we want to implement. First one is the server-side code generation. So having this description, we can use a utility which will generate 90% of the code developed by the developer in order to lay down all these data structures, the hierarchy of these Merkle trees, the transaction specification, and so on and so forth. So the only thing that the developer needs to specify after this code generation would be the actual business logic, how the transaction is executed, or how the transaction changes the data inside the blockchain. And the second thing is what we call unified light client. So at the moment, light client is library. It can check this the cryptographic proofs that we have, but you need to tune it for every specific project in Exonum, because the hierarchy of these Merkle trees that there are in the database is different for each of the projects. And that's why you need to have also a front-end developer, which need to put some code which will be in correspondence with the backend code here. So if we will store in the blockchain an interface description, this means that we will be able, from the light client side, to download this description and understand the hierarchy of the Merkle trees. And this means that without any additional changes and without any tuning, light client will be able to communicate with any instance of Exonum blockchain. And this gives you clues to very interesting applications. So you can develop, for example, an application with the Exonum light client inside that can be a single wallet, for example, for any Exonum-based cryptocurrencies. Just the idea for you. So you have, I don't know, 100 cryptocurrencies based on Exonum, and you have a wallet which will be connected to all of these cryptocurrencies and will be checking the proofs simultaneously and using just the same piece of code. So from my point of view, I really enjoy this feature, and I really like it, and we are already working towards it. There are also some additional changes about the services isolation, about transaction improvements, networking improvements. You can see everything from here on our website. And actually, I would like to share with you the website, just for you to know how it looks like. Just give me a second. So you can go to the site exonum.com, and you will see here the Exonum website. Here you can look through the information on the website. It's very simple. You can just scroll and see all the information here. We have some demos there. The demo for the timestamping, the digital rights management. We have some solid use cases that we already run when we are working with governments. We have a blog also, and also the links on the GitHub. But because a lot of guys here are very techy guys, you can go right through to the documentation and look through the documentation that we have already. So, and you can go through the tutorials and how to use it, and very easy, next steps that you can perform by yourselves. And of course, we also have the GitHub company. It is called the company Exonum, and you can see several of the repositories here. So the core repository, and as I said to you earlier, we have additional modules. For example, Exonum BTC anchoring is one of the modules, and you can look at it and you can try to work with it. You can download it. It is available for free. Yeah, so that's it. Thank you very much, all of you, for coming here. I really appreciate your time and the ability to talk to you and say you a little bit about Exonum. And in order to contact us, you can use our website or our email address, or you can, or if you're a developer, you can just go straight to the GitHub and file some issues or even contribute some code. That's it. Thank you very much.
Okay, I think we have some. Thank you, Alex. I think we have some time for questions. There are two options. The question from Adam Smith. Is it any protection from new malicious block generation, proof of work, in case of hacked network, new nodes adding? I think it's a good question to announce for everyone.
Okay, so the protection from the malicious block generation because of the new nodes that connect to the network. So because we have this notion of validator nodes, or the miners, like in the Bitcoin blockchain, and these validator nodes are permissioned, which means that not everyone can join the network as a validator. This means that we start the network with, for example, 4 validators, and these validators decide whether they want to add new validator to the network or not. So these guys are actually ruling the blockchain, and only the decision of these validators is able to change the list of the validators, is able to change the configuration of the system. So if there is a case when these validators added some additional members, and these members generate malicious or incorrect blocks, these blocks are discarded unless there are more than 2/3 of the validators that want to add this block. However, if there are a lot of validators that want to add malicious block, then this is traceable. They add this block, and anyone can see that these validators signed this block, which means that these validators agreed with the information which is stored in this block. So, very visible, very transparent system. Anyone can understand who voted for what, and this means that all the malicious behavior will become very visible at the very beginning of this behavior. So that's it. And if the validators want to have a double bookkeeping, so they want to have one version of the blockchain which will be for public, and the second with the malicious blocks that they want to hold private for themselves and maybe reveal it a little bit later. Then when we come to the points of anchoring, they need to decide what information they would anchor. If they anchor the right version, the public version, then this means that the history of the blockchain, which was previously done for the private version, will not be able to be proven by the anchoring algorithm. Yeah. So each time we come to the anchoring point, the validators say to the world that this version of the history is correct. Again, very traceable, very transparent system. Does it answer the question?
I think so.
Look sometime through the website. Soon we are going to have the emailing lists also available, and you will be able to subscribe to it. We just didn't want to put too much marketing there. We just want to produce a good quality product. So we were not focusing on the marketing, and that's why we're starting with the technical audience at the moment. Yeah, but sooner or later we're going to add some additional features, and if you want to stay tuned, you will be able to join this newsletter.
Alex, probably the last question. I think it's again interesting question. What is the cryptocurrency which can be used on the network? Does that have any standard? I'm just seeing the question. Yeah, you see the question.
Yeah, I see the question. Okay, so we do not need to. You do not need to have a cryptocurrency within your version of within your instance of Exonum blockchain, and there is no some kind of standard for the cryptocurrency. Yes, we do have a demo of cryptocurrency in the GitHub, but this is just about the thing that you can play with. Ideally, we or maybe someone from the community will develop a solid example of a cryptocurrency service, which can be then reused by many of the parties. The possible use of the cryptocurrency in coins or tokens and the mining process, or is this direct allocation by creator, how we can benefit from it. So you can put into this smart contract of the cryptocurrency any logic that you want. If you want to state that there is some certain amount of coins available from the start of the network, so then you put this information into your service. So you said that there is, I don't know, maybe 1 billion of the coins available at the beginning, and all of them are on this wallet, and there is no such transaction as create new coins. So this can be incorporated into the business logic of this service. Or alternatively, you can put some information about how the cryptocurrency is injected to the market. For example, a creator of the block, so one of the validator gets his some additional cryptocurrency like in the Bitcoin. Or, for example, you can put some inflation, just a simple inflation into the system, and I don't know, maybe every holders of the tokens get some additional percent of the tokens during the network operation. Or, for example, you can introduce a regulatory body who and only who can issue some new tokens or get the tokens out from the market. So actually, because we do not have any of these mechanisms inside the Exonum itself, we just have just a database with the smart contracts or with services, as we call them. Then you are able to implement any of the logic. So but still it is, well, it is needed to be implemented. Okay, I hope this was useful for you.
Okay, guys, let's wrap up. Thank you all for joining us. Once again, stay tuned.
Thank you, guys. Bye.